Hello and welcome back to the channel. So in this lecture, we are going to talk about HDFS, which is the most important service in your Hadoop ecosystem. So HDFS is a primary storage for all your Hadoop services. So in the previous lecture, we have seen how to work with HDFS on either a web UI, which is Ambari, and also through a command line interface where we have downloaded Putty, which is a terminal to communicate with your Linux machine. And we have run some simple operations by using copyFromLocal command. We have made the directory as well as remove the files after the session. But we are not aware how the HDFS works in the backend. And you should be aware what is going on in the background when you are running a code on your cluster or else just running some simple commands through your command line. Here we will see some introductory part to HDFS. After that, we will go to the HDFS architecture. Then we will cover how HDFS stores its data in a distributed manner. Also, we will cover the rack awareness, which is a very important topic in HDFS. And then we will see some basic commands to manipulate data in HDFS. So without further ado, let's get into it. Basically, HDFS is designed for storing very large files running on the cluster of commodity hardware. So commodity means it should be cheap and easily replaceable. The design principle of storage of less number of large files rather than having a huge number of small files. That's why the HDFS will provide the fault-tolerant storage layer for Hadoop ecosystem components. For maintaining this fault tolerance, HDFS has a concept of replication, which will replicate the blocks of storage to maintain the fault tolerance system. It stores the data reliably even when any of the hardware fails and provides a high throughput for accessing all the applications by providing parallel access to our data. So now let's go towards HDFS architecture. In HDFS architecture, there are two main nodes which are running on your cluster. The first one is a NameNode and second one is a DataNode. So NameNode is also known as a master node. NameNode will be a high-end machine and not like the commodity hardware which we will use as a slave node, which is DataNode. This NameNode will regulate file access to the clients as well as it maintains and manages the slave nodes and assigns tasks to them. It also executes some file system operations like opening, closing, and remaining files and directories. And it stores the metadata like the file names, the number of blocks, the replication factor, as well as the location of the blocks and blocks ID, and so on. And this metadata is available in memory for faster reading and writing of the data. And our second node is a data node, which is also known as a slave node. So as the name suggests, slave node is nothing but a commodity hardware and there can be n number of slaves in your architecture. And these are horizontally tied together to achieve the horizontal scalability of the cluster. So these slave nodes are the actual workers who does all the groundwork and serves the read and write request from the file when client submits any request. So they will perform block creation, deletion, replication as per instructed by the NameNode. So once there is any file coming to the data node, this will handle all the replication. So what is replication? That we will see in the next topic. So now we will discuss how the data is stored in our HDFS. So HDFS will break the data files into a smaller pieces of data which is known as blocks. And the default size of HDFS is either 128 MB or 256 MB. So for example, if you have a 640 MB of file and our block size is 128 MB, then it will divide this file into 5 parts and store it into data nodes. And after that, it will store it in distributed manner on different nodes. So this will provide a mechanism for MapReduce for processing the data in parallel way over the cluster. Also, HDFS will store multiple copies of each block across the cluster of different nodes. So as in when if one data node fails, there will be one replica present on the other data node to achieve the fault tolerant system, which will make it highly reliable and highly available storage layer. Now we will discuss one of the most important topic in HDFS, which is rack awareness. But you might ask, what really is a rack? So rack is nothing but a collection of multiple data nodes connected using a network switch. So as you can see in this figure, this is the rack which contains 3 data nodes. And there could be multiple racks in your cluster. So when the network will go down, the whole rack will be unavailable. To deal with that, that's why we are using a replication in HDFS. But you might ask, what really is a rack awareness in HDFS? So on the production level, there will be multiple racks and each rack will have multiple data nodes present. And the communication between these data nodes on same rack will be more efficient as compared to the communication between data nodes which are residing on different racks. So in this example, if we take an example of block 2 and block 3, the communication between these two blocks will be easier than the communication between the block 1 which is present on the rack 1 and the block 1 present on the rack 2. So for reducing this network traffic during read and write operation, NameNode will choose the closest data node for serving the read and write requests. So let's consider, if we have one file having the 3 blocks, then HDFS will try to keep those 3 blocks as close as possible to minimize the read and write overhead whenever client will submit their request on HDFS. And NameNode will maintain all the rack IDs of each data node for achieving this rack information. So the rack awareness is nothing but the concept of choosing the closest data node based on the rack information. So this is how rack awareness works. But why it is needed? So the obvious reason is for reducing the network traffic whenever we are doing a read and write operation on your HDFS, which will improve the cluster performance. So when you have one file having a 3 blocks, then HDFS will try to store it as close as possible, but also maintaining the fault tolerant and replication factor. So whenever entire rack goes down, the other rack will have the replica of the same block. So that's why it will achieve a highly available system and the data will be available even in the unfavorable conditions. So this was the whole concept of rack awareness. But it has some specific rules bound to it that we will discuss now. The first one is there should be not more than one replica be placed on one data node. So if the replication factor is 3, which means each and every block should be replicated 3 times, then not more than one replica should be present on a data node. So it either should be present on one rack but not one data node. The second awareness policy is not more than 2 replicas are placed on the same rack. So let's consider, if we have a one block which should be replicated 3 times, so only 2 replicas should be present on each rack and the other one should be placed on the closest rack as possible. And also the number of racks used for block replication should be smaller than the number of replicas. So if the number of replicas are 3, then those 3 replicas should be present on less than 3 racks, which means it should be present on 2 racks to achieve highly available system as well as to achieve replication and highly reliable. I think this basic knowledge will be enough for your understanding of HDFS. Now let's talk about some features of HDFS. The first one is distributed storage. As we already discussed, HDFS will store the data in distributed manner. So it's nothing but it divides a data file into smaller chunks and store it on the different data nodes. So in this manner, HDFS will provide a way to map reduce for processing a subset of large dataset which are broken down into smaller chunks known as blocks parallelly on several data nodes. The second one is a replication. So as we already discussed, HDFS will replicate your blocks to achieve the fault tolerant system. So replication means nothing but creating a duplicate copies of each block. This is known as replication, and all the blocks are replicated and stored on different data nodes across the cluster, which will make it a highly available and reliable system. So that's what the next feature, highly available, as the replication of data blocks and storing them on multiple nodes provides highly availability of the data. And as seen earlier, the default replication factor will be set to 3, which means each block will have 3 copies of file stored on the data node. But we can change it as per our requirement by editing the configuration file, and the file name is hdfs-site.xml. The next feature is a reliability. So as the data is replicated multiple times, it will increase the reliability of the system. So whenever some node will crash or some hardware will fail, the replica of the files which is present on the failed node will be present on other data nodes. Also, if an entire rack goes down, the block will be still available on the different rack, as we have seen in our previous topic where we discuss about rack awareness. Our next feature is fault tolerant. As you already know, HDFS works with the commodity hardware specifically for the data nodes, and there will be higher chances of getting it crashed or burnt, whatever it is, at any time. So that's why we will use replication for storing multiple copies of data, and this will make the system fault tolerant. So whatever the condition, it will deal with it and your data will be safe on your cluster. And the last feature is scalable. So let me tell you 2 major ways for scaling. The first one is vertical scaling and second one is a horizontal scaling. So vertical scaling means scaling in a vertical manner. So if you have a PC with 8 GB of RAM, so vertical scaling means you will upgrade the RAM to 16 GB to make it twice as powerful. But horizontally scaling means instead of increasing the RAM, you will get another 8 GB of RAM and you will do all your operation in a horizontal manner. But what is the benefit of horizontal scaling? Since you already know that vertical scaling will have some limit, so you can only upgrade to a certain level if we are talking about hardware. But if you buy some cheap commodity hardware and join them in a single cluster, that will make it a very effective and a very powerful system. And you can also add n number of horizontal hardware without any limit. So that's why it makes it a scalable system. So you already know in HDFS we are using commodity hardware joined together in a horizontal manner. This will make it a scalable system. Now our next topic is HDFS operations. So there are major 2 operations we are doing on HDFS, read operation and write operation. So let's discuss them one by one. Now let's talk about what is read operation and how it works in the backend. So for read operation, whenever a client wants to read any file from HDFS, so let's consider we have a file named sample.csv, and if you want to read it, then the client needs first to interact with NameNode, since NameNode will have all the metadata about all the blocks present on the data nodes. So NameNode will specify the address or location of the slaves where the actual data is stored. Then the client will interact with the specified data nodes and read the data from there. For security purpose, NameNode will provide a token to the client, which will show to data node for reading the file. So in read operation, if the client wants to read any data which is stored in HDFS, first it needs to interact with the NameNode, since NameNode will handle all the data nodes present in the cluster. So when clients goes to data node for reading the file, after checking the token, it allows clients to read a particular blocks present on the cluster. And then client will open the input stream and start reading the data from specified data node. And in the write operation, it will have a similar kind of process. Here also client needs to interact with the NameNode first, since it has all the information of data nodes and the address of the block. So NameNode will provide all the address of the slaves on which the data has to be written by the client. So once the client finishes writing the block, the slave then starts replicating the block into another slave. So slave means data node, which then copies the block to the third data node. So this is the case when the default replication factor is set to 3, which we have discussed earlier. So after replicas are created, it will send a final acknowledgement to the client, and the authentication process will remain the same what we discussed in the read operation. So this is how the read and write operation works in HDFS. Now let's talk about some basic commands in Hadoop. So as we already worked with the HDFS through command line interface, these basic commands are similar to Linux. So if you are familiar with shell scripting, this will be easy for you. The commands will be same, just with some modification. So before giving any Linux command, you have to mention either Hadoop space fs, otherwise you can also use HDFS space DFS, which is given here. So as you already know, ls is a command for listing the files. So here you can use HDFS DFS -ls, and you can also give the directory to list out the files present in that directory. And there are several options for ls command. So if we give -d command, so it will also list the details of the specified folder. In this case, Hadoop. If we use -h, it will format the file sizes in a human readable fashion. Instead of giving this whole number, it will show it as 64 million. If you use -R, it will list out all the files in Hadoop directory as well as the subdirectories present in the specified directory. And for pattern matching, we can use the star to get the files having the matching pattern. So this is all about listing files. The next one is reading and writing the files. So the first one is a text command. So it will take any file. So here in this example, derby.log is the file, and it will output it as a text format on terminal. The next one is a cat command. So I hope you already know the cat command will display all the content in your file stored in HDFS. So HDFS DFS -cat, and you should give the path where that file resides. And the next one is a append to file. So you have to see the capitalization wherever required. So it is very important to note. So the append to file command will append the content of this local file test1 into the text2 file which is present on the HDFS. Then we have the commands for uploading and downloading the files. So we have already discussed some of those commands, such as copyFromLocal, which will copy the file from local system and paste it to Hadoop system. So similarly, there is a put, which will copy file from local system to HDFS. It is similar to copyFromLocal. So if the given file is already present in HDFS, then we can use a -f option for overwriting that file. The -l option will forces the replication factor of 1. Then there is a -p option, which preserves the access and modification times as well as the ownership and mode information. After that, there is a get, which copies files from HDFS to local system, which is opposite to put command. And a similar -p option will be passed to preserve the access and modification times. Also, we have copyFromLocal, copyToLocal to copy file from local system to HDFS, and for copying HDFS file to a local system. And we also have moveFromLocal, which is similar to put command, but the source file will be deleted after it's copied. So these are all some basic commands for uploading and downloading the files. And the last one are for file management. So the cp command will copies the file from source to destination on HDFS. So it will transfer the files within the HDFS. So using the -p with cp command will preserve the access and modification times, ownership, and the mode as well. And if we use -f, it will do overwrite if the destination already exists that file. Also, we have the mv command for moving the files, and RM for removing the file or deleting the file. And also there are many other commands such as mkdir which is used for making the directory, and rmdir for deleting that directory, which we already executed in the previous lecture. So this was all the basic information you need to know if you are working with HDFS. So in this lecture we have covered some introductory part of HDFS. After that we have seen the architecture, rack awareness, and how the data is stored into HDFS. After that we have seen how the read and write operation are executed behind the scenes. Also we have seen the basic features, and at the last we have discussed some basic commands of HDFS. So if you are familiar with Unix shell scripting, then it's easy for you. So if you like this lecture, please subscribe to our channel and also ring the notification bell to get the latest updates. And don't forget to follow us on our social media that I have linked in the description below. Thanks for watching.